Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is week 3 of classes in Term 1B. And big announcement, I guess, is that for this week only, PLAR Math will be broadcast Monday and Tuesday because Jovi is sick today and she has an appointment tomorrow. And then PLAR Science will be broadcast Wednesday and Thursday this week. So that's PLAR Math today and tomorrow, and PLAR Science Wednesday and Thursday for this week only. Two ways to participate in classes. The usual ways, you can call into our studio using our 1-800 number or our local number, or you can join our classes using Zoom, and the instructions for joining a Zoom class are in your study guide. All PLAR English students are welcome to attend classes, so it doesn't matter if you signed up for PLAR IL or PLAR Radio Zoom, you can still attend the Radio Zoom classes. The information that we cover is the same for both. The packages that you get for IL and for Radio Zoom are the same package. To contact me, you can use email, phone, or send a message on Facebook, and all of my contact information is on the cover page of your study guide, as well as the cover page for every lesson. Also, the information for joining Zoom is there, for calling into our studio, listening to classes, all that information is there. Students who are still working on the PLAR from Term 1A can keep working on the key questions or the culminating activity and continue to submit to your teacher. So if you started PLAR in 1A, or even if you're continuing on in 1A, keep working on it in 1B. PLAR students are not withdrawn, and you do not have to reapply until the new school year. So you apply once in the school year, and then you are on our list for the rest of the year. The recorded classes from last term and last year are still available on the WASA YouTube channel. So to find that channel, first go to YouTube and search for WASA Distance Education Center. You will see our WASA logo and our name. You might have to look carefully because it's kind of small, but it is there. So click on either the logo or the name. Then once that page opens, once our YouTube channel opens, you will see a random selection of classes. It's not the playlists, and you don't want to have to look through all of those classes to find the one you're looking for. So go to playlists in that list there under our logo. Click on playlists, and then you will see our page open up, the playlist page open up, and here you will see all of the classes, the playlists for all of the courses that have been offered this year and last year. So for example, the PLAR English is there from this year, so from last term as well as last year, and the same thing with the PLAR History and the PLAR Science. So when you scroll down, you will see PLAR Math 2025, 2026, but also PLAR Math 2024, 2025. So if you are working ahead of where we are in class, so we're still working on lesson 1 right now. If you're working on lesson 2 or above, then go to the 2024, 2025 PLAR Math playlist for those classes. The material for the PLAR Math hasn't changed, so everything you need will be there. Just make sure you click on View Full Playlist. Okay, once you click on View Full Playlist, the playlist for the PLAR Math 2024-2025 will open up, and then you will see only the PLAR Math classes. So look for the lesson that you are working on or the key question. All of the classes are organized by lesson number and key question. So if you're stuck on key question 19, then go to PLAR Math lesson 3, key question 18, lesson 4, key question 19. Click on that class, and then you can watch the whole video, or you can scroll through to find what you're looking for. Just a reminder that at the end of every term, WASA has 2 student draws, one for students who earn a credit during the term and one for students who submit work during the term. So for every lesson that you submit, your name will be entered into the student work draw. For every credit that you earn, your name will be entered into the credit draw. So for students, PLAR students who are working on the culminating activity, if you submit your culminating activity, your name will be entered into the student work draw. If you pass your culminating activity, your name will also be entered into the credit draw. And for PLAR students, you know that you can submit more than one culminating a term. So if you finish 3 culminatings in the term, then you get 3 chances for the student work draw and for the credit draw. So try to do as much as you can without really rushing. All PLAR students have the option of writing the culminating activity instead of doing the lessons and the key questions, even if you have completed and submitted some of the work already. So for those students who are in the workforce, you didn't finish school, but you have been working, you've been using your English skills, so writing, reading, or your math skills, calculating things, different things, then and you started working on the lessons and you're finding that the lessons are really easy, it's stuff that you already know and you're just kind of breezing through it, then you're probably better off just going to the culminating activity, doing that, and you'll probably pass it. If for whatever reason you don't pass the culminating activity, then you will have to do the lessons and then you write another culminating activity. So if you want to, you can try the culminating activity up front. If you fail it or you find that too difficult, then you can choose to do the lessons. For someone who hasn't been in school for a very long time, then it's probably a good idea for you to try the lessons first. So just think about what your skills are like. And remember, it's grade 9 and 10, so it's not terribly difficult. So you can try the culminating activity if you want to, but depending on, like I said, what you've done since you've been out of school, it might not be easy for you and you might need to do the lessons as a refresher before doing the culminating activity. So let us know what you want to do. If you do choose to do the lessons, there are 2 types of questions to be answered, the support questions and the key questions. The support questions are the practice questions that are scattered throughout the lesson. So you'll read a section, there will be a support question. Read another section, there will be another support question. The answers to the support questions are near the end of the lesson, right before the key questions. So as you do the support questions, go to the end and check your answers. If you are doing really well with the support questions, you're not making too many mistakes, then you can go on to the key questions. The key questions are the questions that I mark, and you will notice that it says 10 marks or 12 marks or 9 marks or whatever. Okay, the support questions do not have marks because they're practice and the answers are there. So do not send me the support questions. Okay, when it comes to submitting your work, the first way is to give it to your DEC, who will send it out to us here in Sioux Lookout. If you don't have a learning center or a DEC in your community, you can submit your own work. Few ways of doing that, but remember, if you are submitting your own work, be sure to write your name on your work. Your name on the first page and then initial all of the other pages that you're sending. Okay, if you have access to a scanner, you can scan and email your work to our studentwork@nnec.on.ca email and make sure you CC it to me. If you do not have a scanner, but you do have access to a fax machine, you can fax it to our 1-800 phone number, or fax number, sorry. If that doesn't work for you, no access to a scanner or a fax machine, then you can use your smartphone. With your smartphone, you can either take photos of your work or scan your work, and then you can either email it to that same student work email and CC it to me, or you can send it using Facebook Messenger. Okay, whichever one works better for you. Also, if you live in Sioux Lookout or you live in the surrounding area and you come to Sioux Lookout very often, you can stop by WASA on Front Street right beside the post office to drop off your work. You can either drop it off in our outdoor mailbox, which is located in the parking lot at the side of the building, or you can ring our doorbell at the front door on Front Street and give it to the person who answers the door. You can also use Google Docs to complete your work, and then you can send me the link. Make sure that the link is shareable. Okay, so that's our announcements. We're going to do a quick review of what we've been working on so far. And so far in the lesson 1, we've been looking at integers. We've been learning how to add, subtract, and multiply and divide integers. So just a quick review, there are rules. So there are rules for everything in math, pretty much. So the thing that you have to remember is that you have to learn the rules, you have to remember them, and then you have to use them. And the more you use them, the easier it becomes for you to remember them. And then you don't even really have to think about it, you just know what to do and you do it. So for addition of integers, if you are adding 2 integers with the same sign, or even 3 or 4 integers and they all have the same sign, then your answer will have that sign. So for example, if you're adding a positive plus a positive, your answer will be a positive. So positive 4 plus positive 8 will give you positive 12. If you're adding all negative integers, then your answer is also going to be negative. So a negative plus a negative will give you a negative. So for example, negative 6 plus negative 3 will give you negative 9. So same sign. If you're adding numbers with the same integers with the same sign, then your answer will have that sign. If you are adding integers that are opposite, so a positive plus a negative, then you have to use the sign of the larger absolute value number. So you have to look at your numbers in this case. So for example, 12 plus minus 7. So you look at the number without the sign. That's what absolute value means. So you've got a 12 and a 7. Now your answer is going to have the sign of the bigger number, bigger absolute value. So 12 is bigger than 7, it's positive, so that means your answer is also going to be positive. That's for finding the sign. For finding the number for your answer, you are going to subtract the numbers that you have, the absolute values. So 12 take away 7 equals 5, and because 12 is positive and it's bigger, then your answer is going to be positive 5. Okay, 10 plus negative 14. Again, look at your numbers. 10 and 14. 14 is bigger than 10. 14 is negative, so that means that my answer is going to be negative. Then to find the number part of your answer, subtract. 14 take away 10 equals 4. So that means that 10 plus negative 14 is negative 4. Okay, if you're adding a negative and a positive number, same rules apply. So we get negative 13 plus negative 16. Look at the absolute value. 13, 16. 16 is bigger than 13. It's positive, so your answer is going to be positive. Then subtract your numbers. 16 take away 13 equals 3, so the answer is positive 3. Negative 9 plus 7. Look at the numbers only. 9 and 7. 9 is bigger. 9 is negative, so your answer is going to be negative. And then subtract your numbers. 9 take away 7 equals 2, so the answer is negative 2. Okay, so those are the addition rules. Subtracting integers uses a change and then using the addition rules. So basically what we're doing when we're subtracting integers is we are changing the subtraction to addition. So the rules say that we keep the first number. In this first example, the number is 4. Then we change the minus sign to plus. And we change the number that we're subtracting to its opposite. So a positive 7 becomes negative 7. So we end up, when we make those changes, with 4 plus negative 7. Now we've got addition, so we use our addition rules. So we've got a 4 and a 7. 7 is bigger, 7 is negative, so our answer is going to be negative. 7 take away 4 is 3, so our answer is negative 3. Example B, negative 1 minus 9, keep the negative 1, change the minus to plus, change the positive 9 to a negative 9, and we end up with negative 1 plus negative 9. Now they're both negative, so their answer is going to be negative, and 1 plus 9 is 10. And C, negative 3 minus negative 5, keep the negative 3, change minus to plus, change negative 5 to positive 5, so we end up with negative 3 plus positive 5. 5 is bigger than 3, it's positive, so our answer is going to be positive, and then 5 take away 3 is 2, so our answer is plus 2. Okay, I mentioned before that if you have, there's a shortcut, so if you have, in this last example, you have minus a negative, all you have to do is change both of those to plus. So you still end up with negative 3 plus positive 5. But that one's just a bit of a shortcut. Okay, so for multiplying and dividing integers, the rules for multiplying and dividing integers are the same. So the rule tells us that if the signs are the same, then the result is positive. So when we multiply, when we add, we get a sum. When we subtract, we get a difference. When we multiply, we get a product. So the product of two numbers and multiplying the two numbers of the same sign is always positive. So positive 2 times a positive 5 will give you a positive 10. And negative 2 times a negative 5 will also give you a positive answer because the signs are the same. Positive times positive, negative times negative. Your answer will be positive. Same thing for dividing. If your signs are the same, your answer is going to be positive. If your signs are different, your answer will be positive. So 8 divided by 4, that's a positive 8 divided by a positive 4 equals positive 2. Negative 8 divided by negative 4 also equals a positive 2 because the signs, again, are the same. Positive divided by positive, negative divided by negative. If the signs are different, then the result is negative. So we've got a negative 2 times a positive 5, different sign, so our answer is going to be negative. 2 times 5 is 10, so negative 10 is my answer. If we have a positive 2 times a negative 5, same thing. The answer is going to be negative because one of the numbers is negative. Again, 2 times 5 is 10, so our answer is negative 10. Excuse me. Division, negative 8 divided by a positive 4, so different signs, my answer is going to be negative. 8 divided by 4 is 2, so negative 2. Again, 8 divided by negative 4, different signs, so answer is going to be negative. 8 divided by 4 is 2. Now, generally, we do not put a negative sign in the bottom of a fraction. Our negative sign is either at the top, like in the first one, negative 8, or it's right at the bar line, the fraction line, not in the bottom. Okay, so those are the rules for adding, subtracting, multiplying, and dividing integers. So now we are done with integers. Now today we're looking at fractions. So today we're going to look at what fractions are, and we're also going to look at reducing fractions. So in your lesson on page 17, we start looking at fractions. So page 17 goes through what fractions are and the parts of fractions. Page 18 looks at how to change improper fractions to mixed numbers, and we also have support question 5 there for you to do. So let's have a look at fractions. So a fraction has two parts. The number on the top of the fraction is called a numerator, and it tells the number of equal parts taken. So if you are taking one of the parts away, then that one at the top is the number that we're looking at. So the number on the top will tell you how many parts you're taking or you're leaving or eating or whatever. The number on the bottom is called the denominator. So when you think of trying to figure out which one's a numerator and which one's a denominator, think of the denominator starts with D and the word down So it's down below. Starts with D as well. That might help you remember. So the denominator tells the total number of equal parts in a whole or in a collection. So basically it tells how many parts we are dividing the whole or the collection into. So what are fractions? Fractions represent equal parts of a whole or collection. Now you have to remember that fractions are equal parts. They're not just random parts, they're equal. So the fraction of a whole is when we divide a whole into equal parts. Each part is a fraction of the whole. So for example, if you take a whole watermelon and you cut it into 2 equal pieces, then you end up with 1 of the 2. Okay, so each piece is 1 of the 2. If you take that watermelon and you cut it again, you get the watermelon being cut into 4 equal pieces, which is the bottom number of our fraction, and each piece is 1 of the 4. So we get the fraction 1/4. So remember, the bottom number tells how many parts the watermelon or whatever is being cut into, and the number on the top, the numerator, tells how many parts are eaten or how many parts are left. So if we look at this one here, there's 1, 2, 3 parts of the watermelon left. There were 4, so 3 of the 4 are left. 3/4 of the watermelon is left. But we can also have a fraction of a collection. Fractions can also represent parts of a set or collection. So for example, in this picture here, we have 5 animals. Okay, so it's a collection of animals. So what fraction is cats? Well, there's 1 cat, there's another cat, and there's another cat. So 3 of the 5 animals are cats. What fraction is dogs? There's 2. So 2 of the 5 are dogs. So 3/5 are cats, and 2/5 are dogs. We can also represent fractions on a number line. So if you look at a ruler, for example, it's the same thing as a number line, except it only goes in one direction. It's only positive, whereas a number line has negative and positive. But you can see fractions on a number line as well. So in first number line, we have the fraction 1/2. So from 0 to 1, that's your whole. Halfway between, if we divide that line into 2 equal pieces, then we have the fraction 1/2. The next one, number 2, if we divide the fraction into 3 equal pieces, then we get the fraction 1/3. So each one of these pieces is 1/3 of the whole. 2 of them together is 2/3 of the whole. And we can do the same thing by dividing the line into 4 equal pieces, 5 equal pieces, 6 equal pieces, 7, 8, 9, 10, as many as we want. And then the number of pieces that we divide that line into will be the bottom or the denominator of the fraction. So there are lots of ways to represent fractions. Some examples of fractions. Here we have, first is a whole. This is not actually a fraction, it's a whole, so it's the number, it represents one circle, one ball, whatever. The next picture, the ball is cut into 2 equal pieces, so each piece is 1/2 of the whole, so 1 of the 2 pieces. The next is a representation of 1/4, so 1 of the 4 pieces of that circle is yellow. The next one represents 3/4, so 3 of the 4 pieces of that circle are yellow. Okay, some real life examples. The most common examples of fractions from real life are generally things that are in a square or a rectangle or a circle, because it's easier to divide them up. So you can cut a pizza into equal pieces, a watermelon, an orange, a lemon, or whatever. Non-examples. So when the parts of the whole are unevenly divided, they don't form fractions. Okay, so in the bottom, we've got a pizza that's cut into random size pieces. They don't represent fractions because they're not equal. Same thing with the circle, the triangle, and the square. Those pieces are not equal, so they don't accurately represent fractions. Okay, so the next thing we're going to look at, now that we know what fractions are, is changing mixed numbers to improper fractions. So on page 19 is information on how to do that and support question number 6. So do support question number 6, then check your answers at the end of the lesson. Okay, so mixed numbers and improper fractions. So there are different types of fractions. So we just looked at some what we call proper fractions. They have the number on the top is smaller than the number on the bottom. That's a proper fraction. A mixed number is a number made up of a whole number and a proper fraction together. So for example, 2 1/3 is a mixed number. So 2 represents 2 wholes, so 2 whole circles, 2 whole pizza, 2 whole oranges, whatever. So that's your whole number. The 1/3 is the fraction. So then we have a circle that's cut into 3 equal pieces, and one of them is purple. So that represents 2 1/3. So this is a mixed number, or it's often referred to as mixed fractions. Okay, so an improper fraction is a fraction where the numerator, so the number on top, is greater than or equal to the denominator. So 7/3 is an improper fraction because 7 is bigger than 3. The numerator is bigger than the denominator. So we can draw a picture to show you 7/3. So here we have 3/3 and 3/3. That will give us 6/3. And then the last circle only has 1/3 that's purple, so that gives us 7/3. So improper fractions are sometimes called top-heavy fractions because the top is heavier than the bottom, or bigger. Okay, so now to convert a mixed number to an improper fraction. So the mixed fraction 2 1/3 and the improper fraction 7/3 are the same. So can I get both of it on the screen? Barely. So here, if you look at it, we've got 2 complete circles and then 1/3 of another circle. So that represents 2 and then 1 of the 3. 7/3, if you look at the picture, is the same thing. We've got 2 holes and 1/3 of the next one. So that's still 1, 2, 3, 4, 5, 6, 7. 7/3 or 2 1/3. So they represent the same amount. Mixed numbers and improper fractions can show the same amount. So like I said, 2 1/3, 7/3, they are the same. Let's say you have a mixed number and want to write it as an improper fraction. And that's something that you're going to have to do when we get into adding, subtracting, multiplying, and dividing fractions. You will have to change them. So to do that, to change a mixed number to an improper fraction, there are 3 simple steps. Number 1, multiply the whole number by the denominator. Number 2, add that number to the numerator. And number 3, write that sum on top of the original denominator. So let's do an example. Change 2 3/4 or 2 3/4 to a mixed number. So first, multiply the whole number by the denominator. So our whole number is 2. We're going to multiply that by our denominator, which is 4. Now, so this is a good time to learn the difference between numerator and denominator. So you're multiplying the whole number by the denominator, not the numerator. 2 times 4 is 8. Next, add that number 8 to the numerator, 3. 8 plus 3 is 11. Now write the improper fraction. So to do that, we write that sum, so 11, on top of the original denominator. We go back here, that was 4. So 2 3/4 is the same as 11/4. So let's do a little bit of practice, but more practice with converting mixed fractions to improper fractions. So what do? Step 1, multiply the whole number by the denominator. So 6 times 8 equals 48. So that's step 1. Step 2 is add the numerator to our product. So 48 plus 1 equals 49. And step 3 is to write that sum over the original denominator, which is 8. So 6 1/8 is the same as 49/8. Okay, number 2, 19 1/4, same thing. Step 1, multiply 19 times the denominator of 4. So 19 times 4 is 76. Take our product, 76, and add the numerator. 76 plus 1 is 77. And then step 3, write our sum, 77, over our original denominator, 4. Okay, so make sure you do all the steps. Think 3 steps. Step 1, multiply the whole number by the denominator. 5 times 2 is 10. Step 2, take that product and add the numerator. Give us the sum of 11. And then step 3, write the sum over the original denominator. So 11 halves. Okay, so again, whole number times denominator. That's step 1. 9 times 2 equals 18. Step 2, take that product, 18, add to the numerator. 18 plus 1 is 19. And then step 3, that sum over the original denominator, 19 halves. Okay, number 5, 1 7/12. So whole number times denominator. 1 times 12 is 12. Step 2, take that product, 12, add the numerator, 7. 12 plus 7 is 19. And step 3, that sum, 19 over the original denominator, so 19/12. Okay, number 6, 2 13/16. So step 1, multiply 2 times the denominator, 16. 2 times 16 is 32. Step 2, take that product, 32, add it to the numerator, 13. 32 plus 13 is 45. And then step 3, the sum, 45, over the original denominator, 16. Okay, so that is how we do that. Just remember the steps. 1, whole number times denominator. Step 2, product plus numerator. Step 3, sum over original denominator. Okay, so now we know how to convert a mixed number to an improper fraction. A mixed number to an improper fraction. Now we're going to do the opposite. So to change an improper fraction to a mixed number, follow these steps. So first, and so when we did it the other way around, we multiplied. So now we're going to divide the numerator by the denominator. So the numerator is the top by the denominator, bottom. So step 2, write down the whole number part of the quotient. And step 3, take the remainder and write it over the original denominator. So we end up always using the original denominator. So change 9/4 into a mixed number. So first, step 1, I'll keep this up here actually. Step 1 tells us to divide. So 9/4, so we do 9 divided by 4. 9 divided by 4 will give us 2 with a remainder of 1. So write down the whole number part, which is how many times 4 will divide evenly into 9, so that's 2. Then take the remainder, which is 1, and put it over the original denominator. So our original denominator was 4, so 2 1/4 is our answer. So 9/4 is the same as 2 1/4. What if there's no remainder? So sometimes you might divide and the number divides evenly, so there's no remainder. Well, that simply means that you have a whole number. So 12/4 is an example. So here are 3 squares. Each square is divided into 4 pieces. So the 4, remember, tells us how many pieces to divide the squares into. So they're divided into 4 pieces, which will give us 12 equal pieces. So first divide the numerator by the denominator. That's step 1. 12 divided by 4. 4 divides evenly into 12 3 times, so there is no remainder, so there is actually no fraction. We have a whole number as our answer. And that might happen sometimes. Okay, so convert 113 twelfths. So you got to divide 113 by 12. Now, there are a couple of ways of doing this. You can use your calculator, 113 divided by 12. And if you do that using your calculator, you will get 9.41666. And that 6 keeps repeating. So you're going to end up with a fraction. Sorry, not a fraction, a decimal. Okay, we don't want a decimal for your answer. We want a mixed fraction, not a mixed decimal, a mixed fraction. So you can divide, use your calculator to get the whole number part of your answer, which is 9, but you can't use this decimal 416 or decimal 417 if we round it. We can't use that because it's a decimal. So we have to figure out what is decimal 416 as a fraction. So to figure that out, we know that 9, so we take our whole number 9 and we multiply it by the denominator 12. So 9 times 12 will give me 108. So now I take that 108 and I subtract it from 113. So 113 take away 108 will leave me with 5. So my numerator becomes 5 and my denominator stays the same. So my answer is 9 5/12. So that's one way you can do it using your calculator, but you can't just use your calculator to get the answer. The other way of doing it is to use long division. I don't think I left myself enough room. Let's put it down here. Okay, so how many times does 12 divide into 113? Well, using your long divisions. Well, 12 times 10 will give me 120. That's too much. So 12 times 9, we already said, will give us 108. So there's my 9. 12 times 9 is 108. 113 take away 108 will leave me with 5. This is my remainder. So that is my numerator, and then my denominator stays the same. So you can either use your calculator or long division, whichever one works better for you. You might be able to do it in your head depending on how good you are at math. Okay, number 2, 19 halves. So I need to divide 19 by 2. So how many times does 2 divide into 19 evenly? Well, 2 8s are 16, 2 9s are 18. So 2 divides into 19 evenly 9 times. 2 times 9 is 18. 19 take away 18 will leave me with 1 remainder, and I use the original denominator, so 9 1/2. Again, if you do it on your calculator, 19 divided by 2, you end up with 9.5. Now, if you know your math, then you know that 0.5 is the same thing as a half. So you just convert it, 0.5 to a half. You get 9 1/2. Otherwise, you have to figure out what it is. 2 times 9 is 18. 19 take away 18 is 1. Number 3, 36 tenths. So how many times will 10 divide into 36 evenly? 3 times. 3 times 10 is 30. So my whole number is 3. And then I've got 36 take away 30, which will leave me with 6. 6 is my remainder. So I end up with 6/10, 3 and 6/10. Now, I wouldn't leave it like that because I know that 6/10 can be reduced, but that's something we're going to look at a bit later on. Okay, so we'll leave it as 6/10 for now. Okay, let's skip down here to number 7. 13 divided by 3. Okay, how many times does 3 divide evenly into 13? Well, 3 fours are 12. That leaves me with 1 remainder, and so my mixed fraction is 4 1/3. Okay, let's do number 10. 27 fifths. How many times will 5 divide into 27 evenly? Well, 5 times 5 will give me 25. 27 take away 25 is 2, so 5 2/5 is my answer. So that's how you change from a fraction to a mixed number. Okay, equivalent fractions. Well, actually, we won't work on equivalent fractions today. We'll do a bit more practice with this because I just want to make sure we get this done. Okay, make sure you're understanding it. So 39 fourths. So how many times will 4 divide into 39? So let's do it using long division this time. So 4 into 39. 4 9s are 36. 4 10s are 40. So it's going to go evenly 9 times. 4 times 9 is 36. 39 take away 36 will leave me with 3. So my whole number is 9. My remainder is 3. And my original denominator is 4. So 9 3/4. Number 9, 68 tenths. How many times will 10 divide evenly into 68? Well, 10 times 6 is 60. 68 take away 60 will leave me with a remainder of 8. So 6 is my whole number, 8 is my remainder, and 10 is my original denominator. So whole number, the remainder, it becomes the numerator of your new fraction, and the denominator stays the same. So make sure you don't change your denominator. Okay, 53 eighths. How many times will 8 divide evenly into 53? 8 times 7 is 56. 8 times 6 is 48. So 48. 53 take away 48 is 5. So my whole number is 6. My remainder is 5. And my denominator stays the same. So 6 5/8. Number 12, 72 tenths. How many times does 10 divide evenly into 72? Well, 10 times 7 is 70. That's pretty easy. 72 take away 70 leaves me with a remainder of 2. So my whole number is 7. My remainder is 2. And my denominator is 10. Same denominator as the original. And again, this one and a couple other ones, number 9, they can be reduced to lowest terms. So we'll look at reducing fractions next day. Okay, so we will go on here to equivalent fractions. So some fractions may look different, but they're really the same. So just like when we changed from a mixed number to an improper fraction, they represented the same amount. They were the same thing, but it was just a different way of writing them. So it's the same thing with fractions. Some might look different, but they actually represent the same amount. So for example, 4/8, 2/4, and 1/12. They are all the same. So if we take a pizza, for example, 4/8 means that we have 4 of the 8 pieces. So the pizza was originally 8 pieces. 4 of them are gone, 4 remain. So 4 of the 8 pieces are still there. And when we look at that, that's like a half a pizza. So if we took the same pizza and instead we cut it into 4 equal pieces, 2 pieces remain, so that's 2 of the 4 pieces. It's still the same amount of pizza. And then the next one, half of the pizza. So the pizza was cut into 2 equal pieces. 1 of those pieces is left, so that's a half. So 4/8, 2/4, and 1/2 are equivalent fractions. They all represent the same amount. But only one of these fractions is written in lowest terms. So this fraction, half, is the one that's in lowest terms. So a fraction is in lowest terms when the numerator and the denominator have no common factor other than 1. So if you look at this fraction, 1/2, 1 is your top number. You can't make that any smaller. It's usually best to show an answer using the simplest fraction, in this case a half. That's called simplifying or reducing the fractions. So to reduce a fraction to lowest terms, there's no whole number other than 1 that divide evenly into both the numerator and the denominator. So 3/4 is in lowest terms because 1 is the only number that will divide evenly. So 3 divided by 1 is 3, 4 divided by 1 is 4. 6/8 is not in lowest terms because 2 will divide evenly. So we can divide 6 by 2 and get 3. We can divide 8 by 2 and get 4. And then we're back down to lowest terms. To change a fraction to lowest terms, divide both the numerator and the denominator by the largest whole number that will go into both of them evenly. So that means when I say go into both of them evenly, that means there's nothing left over. Okay, so if you were to divide 9, if you were going to do 9 divided by 2, well, that will give us, what, 4.5 or 4.5. So that's not evenly. Evenly is when you divide and you get the whole number. Okay, so let's get rid of that. For example, 24/36. The numerator and the denominator can be divided evenly by 2, 4, 6, and 12. Use the largest whole number that divides evenly into both to reduce the fraction to lowest terms. So we can divide 24/36. We can divide both by 2. 24 divided by 2 will give me 12. 36 divided by 2 will give me 18. So we've got 12/18. That's not lowest terms because I can still divide again by 2. 12 divided by 2 is 6. 18 divided by 2 is 9. 6/9. Still not lowest terms because they're both divisible by 3. I'm changing the number, but I'm still dividing top and bottom by the same. 6 divided by 3 is 2. 9 divided by 3 is 3. This is lowest terms because it can't go any smaller. The only thing that will divide evenly into 2 and 3 is 1. So I can do it that way and just keep dividing by 2, by 2, by 2, and then by 3. Or I can divide, same thing, I can divide by both by 2, or by 4, by 6, or I can divide both by 12, which will right away get me to 2/3. Okay, so that's the biggest whole number that divides both into both evenly. Okay, so we are just about out of time today, so we'll deal some more with equivalent fractions tomorrow. But for now, key question 5, change the following improper fractions to mixed numbers. So we're focused on key question 5 today. So we've got 5/4. So remember, to change an improper fraction to a mixed numbers, you have to divide. So how many times does 4 divide evenly into 5? Or again, you can use your calculator, but you have to use your calculator and then use your head. And then number 2, change the following mixed numbers to improper fractions. So now remember what to do. So step 1, whole number times denominator, which will give me the product of 32. Step 2, add the numerator to that product, which will give me 35. And step 3, take that sum 35 and put it over the original denominator of 8, so 35/8. Okay, so take your time, think about the steps you're doing, and show me your work. Write down what you're doing so I can see. That way, if you make a mistake, I can catch your mistake and let you know so that you don't continue to make that same mistake. Okay, so that's it for our class today, and just a reminder that we will be meeting again tomorrow, and when we meet tomorrow, we'll continue on with fractions, and we'll spend some more time reducing fractions.